Well, it's similar to the other one, but notice they gave me the mass in this problem, and I really should do a diagram here because tension is a force. So since it's a rope and I'm swinging something in a circle, then what type of force is causing the change in direction? Is it a T, a friction, or a normal force? It's a T. So we're going to have T in that direction. Right? So that's the first step when you're doing an actual horizontal circle problem is you do the diagram. So if it's a horizontal circle, make the circle look like an ellipse. And then we write our descriptive equation. When we sum up our centripetal forces, there's only one, T. It's the only force that's causing the change in direction, and we know that equals, like anytime we sum up forces, it equals ma. But with circular motion, ma is mv squared over r, or mr omega squared. Like I told you, if I have a choice, I'm always going to use mv squared over r over mr omega squared because my units are going to work out perfectly. The only time I have to use mr omega squared is when r is the unknown. Or, like if they happen to give me the omega in radians per second, I might use it then because then I don't even have to do a conversion. If they just told me what it was in radians per second. So now that I have that, I know the mass, so I'm all set there. All right, so I know the mass is 12.5 kilograms, so it's going to go right there. I know the radius, so it's going to go down there. The only thing I need to do is calculate V, and then I'll have all the numbers to plug in. So let's get what V is, because V wasn't given to us directly, but we have enough information to get it. Because it says in the problem that the mass is twirled so that it revolves once every 2 seconds. So it revolves once every 2 seconds. So my starting point is 1 rev every 2 seconds. And don't make the mistake of putting 2 revs every 1 second, because that's a mistake that I often see in these problems is you end up having the 2 in the wrong place. Because sometimes it is 2 revolutions in a second. And sometimes it's 1 rev in 2 seconds. So that's what it is here. And so I need to just go from revolutions to meters. 1 revolution, what am I going to put in the top? Above the 1 revolution. 2.8. No, well, that's just the R, but 2 pi, yeah. 2 pi times 2.8 meters. And that will give me the V. This problem, we're almost done. All we have to do is calculate that and then plug into this formula, and then we're done. So, I don't know what this is. It's basically pi times 2.8, because the 2's will cancel out. 8.792. That sounds like it could be right. 8.79?
Yeah.
So 8.79 meters per second. And so now my tension, which is what they asked for, what's the tension in the rope, is going to be mv squared divided by r. So the mass is 12.5 kilograms. The V is 8.79 meters per second. And the radius is 2.8 meters. And whatever that is, I hope it's close to 345 newtons. I think that's the answer I have for that.
Yeah, what?
345?
Yeah, 344.9.
Okay. What? If using these numbers, you use these numbers, right? So if I'm rounding off, I get 345.
Wait, so whatever the length of